All right, boys and girls, welcome back to the drive-through. Hope everyone had a great weekend. We're moving on into this week. It's going to be a long week, 5 days plus conferences. Also Spirit Week, so here we go. Today we are reviewing factoring, even though it's well into the year. And once again, I think this is going to be a topic you guys find familiar, and many of you are going to be really good at it. But the key is that you understand what you're doing so that we can apply this, okay? So what is a factor in math? It's a number or a term that is able to be extracted from a polynomial, okay? Well, that brings up a whole other question. What's a polynomial? Well, a polynomial is like an expression with more than one term. That's what poly means. Okay? So, those are some just brief definitions of what we're doing. Let's take a look at what factoring actually looks like. Okay? Let me go this way. So, we've titled this worksheet Review, and there's 4 types of factoring that we're going to do. We're going to review 3 of those on the video and then leave you to practice the 2 really challenging ones on your own. There'll probably be another video for those, but that'll come later. So in this column, we're going to be factoring by the greatest common factor method. Okay? This one, we're going to be factoring with the difference of 2 squares. But more importantly, I want you to understand, these are not equations. These are not equations. They are expressions. They are not equations because they're missing the key thing in an equation, which is a equal sign. Exactly. So you're not solving for these. There's nothing to solve because there is no equation. You're essentially just making these look different. And you just trust that this practice will help you be better at something that's coming down the road. Okay? So, when we're using the greatest common factor method, you ask yourself, what number goes into both of these coefficients? Well, it's a 3. Both of them involve a 3. Then the next question you ask is, what's the highest value of x, or the highest degree of x that goes into both terms? And that in this case would be x, just x to the first. So think about factoring. All it is, it's undistributing. It's the opposite of distributing. So you ask yourself, what did I have to multiply times 3x to get to 9x squared? Well, I know what times 3 is 9? 3. What times x is x squared? X. Then I just test that by going forwards. 3 times 3 is 9. X times x is x squared. Good. Okay, well, what would I have to multiply by 3x to get negative 3x? That would have to be a negative 1. And that's your answer. That's all you do for these. There is no equal sign, so I have to circle it to indicate that I have fully factored it. Essentially what that means is that I cannot factor it anymore. Okay? Okay, so I rearranged the screen for the second one. Okay? And we're just using our calculator here, not in the graphing setting, but just as like an old school calculator with numbers. Because now we might have to do a little guessing and checking to figure out the biggest number that goes into 12, 84, and 96. I think 12 goes into all these numbers, so let's try it. What is 96 divided by 12? It's 8. What's 84 divided by 12? I think it's 7. Yes, okay. So, now we know that the largest coefficient that we can pull out of all 3 of these terms, this is a trinomial, is 12. Okay? The largest value of a, that first of all, this is 3 terms. So this trinomial has 1 term, 2 terms, and 3 terms. Okay? They all have a multiple of 12 in front of them. They all involve at least one a, and they all involve at least one b. So that is our greatest common factor. Over here we said that 96 divided by 12 was 8, so that we know there needs to be an 8 there. We're undistributing. Okay? 96 divided by 12 is 8. A divided by A is 1, that's gone. B divided by B is 1, that's gone. So that's all we have left from our first term. Check yourself. What is 12 times 8? 96. What is A times 1? A. What is B times 1? B. So I could have written this 8 times 1 times 1, but I wouldn't have done that because that's not how numbers are written. So I just wrote it as 8. In the second term, I have a 1 out in front because 12 times 1 is 12. You may not include that 1, which would be totally okay. Now I ask myself, what do I multiply by A to get to A squared? Well, there's going to be another A there. And what do I multiply by B to get to B? Well, there'd be another 1 there. But we don't need to write that 1. In fact, we didn't need this 1 either, but since I put it, I'm going to leave it. Now we know that this next one is going to be a negative. 12 times, we'll go back over here, 84 divided by 12 is 7, so it's going to be a 7 out in front. Notice, A times 1 is A, so there's nothing there. B times what is B cubed? Well, that's going to be a B squared. Okay, so this is my answer. And now I'll check it. Now I will actually distribute it and see if I did it right. So you get 12 times 8 is 96, AB. 12 times 1 is a positive 12. A times A is A squared. B times 1 is B. 12 times negative 7 is a negative 84. A times 1 is A. B times B squared is B cubed. And now I've undid the factoring to get back to the actual answer. So now I know that I did it right. Okay, so hopefully that helps. Okay, so now the difference of two squares. This is a difference, it's a subtraction sign, and this number here, if we can use this method, will always be a perfect square. You might want to write these out. 2 squared, well, I guess I won't skip the obvious one. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. You can keep going, but I'll just stop there, okay? Well, think about this like you are unfoiling. So this is x plus 5 times x minus 5. That is your answer. Now let me just, you don't have to write this down, but it's very important to me that you guys understand what you're doing. So let me show you on a separate paper. Don't even write this down, just follow along. What is x plus 5 times x minus 5? Well, do you remember FOIL? First, x times x is x squared. Outside, x times negative 5 is negative 5x. Inside, 5 times x is positive 5x. And last, now, what is a negative 5x and a positive 5x? That's gone. X squared minus 25. Notice, we have gone, now we've undid what we've just done to check our answer, and we indeed did it right. So that is the method for difference of squares. So this one should be pretty quick. This is x plus 11 times x minus 11. You might be asking, what if I wrote it x minus 11 times x plus 11? Totally fine. Completely right. Okay? I'll circle this. And now the video is almost done. We got one more thing to do. And those are easy trinomials. The word easy, that's just like, we're not saying that this is an easy thing, but when there's a 1 in front of our first value, that's what the easy is indicating. And this is just a riddle, okay? In this one, A is 1, B is 8, C is 12. We could use the quadratic formula to find this, but it would take much longer. It's much easier to think about a riddle. We're looking for two numbers. They multiply to be 12, and they add to be 8. Looking for two numbers that multiply to be 12 and add to be 8. I think that would be 6 and 2. So this would be t plus 6 times t plus 2. Keep in mind, 6 times 2 is 12. 6 plus 2 is 8. That's our answer. Now again, I don't want you to write this down, but I want you to understand what the heck you're doing. Let's look on another page and let's look at t plus 6 times t plus 2. T plus 6 times t plus 2. What I'm doing here is essentially checking my work. First, again, I'm just going to FOIL this. First is t squared. Outside is plus 2t. Inside is plus 6t. And last is plus 12. And indeed, you get t squared plus 8t plus 12. Is that what we started with? Yes. So let's do one more. Looking for two numbers that multiply to be 36 and that add to be negative 12. Okay? Let's see. Well, since they multiply to be positive, they've got to both be negative because they add to be negative. And so I'm thinking, let's see, 9 times 4, that's not it. Let's see, 12 times 3, that's not it. How about 6 and 6? I think that's right. X minus 6 times x minus 6. A negative 6 times a negative 6 is a positive 36. Okay? And a negative 6 plus negative 6 is a negative 12. That is it. Okay? So that could be your answer. You could also write that as x minus 6 squared. I would take either one of those because that's what that means. X minus 6 times x minus 6 equals x minus 6 squared. Let's check our work. You get x squared minus 6x minus 6x plus 36. X squared minus 12x plus 36. Is that what we started with? Yes, it is. So we know that either one of these are correct. Hope that helps. Boom!